So let's change the background. Where is it? Just what I have done. Okay. Here is something page switch background. Sorry. Okay. So in the previous class, we were doing this one. Okay. So let's have the numerical problems. Are you practicing the numerical problem? Because if you are not able to understood this problems, or if you are not doing the, if you are not practicing the problems, then you can face the problems in the next part of this chapter. Okay. So it must be
Yes.
much better for you that if you start practicing the problem. So let me check whether you are able to do this one, because next part is the numerical part portion of this chapter. Okay. And if you are getting stuck in this chapter, in this problem, so first of all, we will keep this chapter aside. We'll keep practicing and we will start the fresh chapter, the that is electrochemistry. Okay. Because that is theoretical chapter from that portion. Okay. And we'll cover up that theoretical portion also. Okay. And we will keep
Okay.
practicing. And when you become good in the numericals, then we'll start the remaining part of this chapter. So it's your choice. But we need to, if we need to study this chapter properly, so what we need to do is that we need to be good, and you need to be good in the numerical problems. Okay. So just a minute, let me check whether
Okay.
okay, we should do some numerical problems, because the students, if you keep on doing this chapter, and you will feel this difficult chapter difficult, because if you are getting stuck in the numerical problem, the other portion will not be, because the other is numerical portions, went off factors. Okay. So first you should be good in this one.
Yes.
So just give me a second. Let me have a numerical. Where were you since last 2 or 3 days? Since you are not attending class,
So
are you out of
I
station?
went to yes, I had to go to UAE because my dad he had an exhibition in his company or something, so I had to go with him.
Okay, then you enjoy it. You know, basically you live in Riyadh.
Yes, I live in Riyadh in Saudi Arabia. Yes.
So let's have a question. So, so is it visible to you on our screen? Other questions?
Yes.
Try to solve it,
Yes.
please. Let's check whether you are
Okay.
starting or not. Okay. And first of all, write down the biography. When you are just solving a numerical problem, write down the biography, that what is given to you, first of all, and what maximum information you can get from the given questions. Okay. Just write the biography, that what is given to you. If suppose this 10% W by W is given to you, what does it means? Okay. Just try to find out, then I'm going to help you. Okay. Do it.
Okay.
Done, Tamim?
No, sir, I'm still there.
Okay, tell me. A glucose solution, a solution of glucose in water is leveled with 10% W by W. Okay, this is what is this given to? By W means weight by or mass
Wait.
by mass percentage. Okay,
Yes, sir.
mass by mass percentage, that is 10%. Okay, that is 10%. Understood? So what would be the molarity and the mole fraction of each component of the solution? Okay, what is asking? What would be the molality and the mole fraction of each component of the solution? It is asking for the molality and the mole fraction of each component of the solution. If the density of the solution is given to you, that is 1.2 gram per liter. Okay, we have done this question previously also, but I want you to be good in the numerical problems so that you can do this one instantly. So what do you mean by the mass by mass percentage? Tell me. What is the
Uh,
formula of mass by mass percentage?
uh, W by,
It is
wait,
the
it's
given mass of
solute,
solute upon
total mass,
mass of solvent or solution.
solution
Okay, solution. And then if it is a
of
percentage sign, then what we have to do?
into 100.
Into 100. Very good. If I need to write it, mass of solute is known as WB. Mass of solution is known as WA plus WB. Means this is solvent and this is solute. Okay, into 100. Is that okay?
Yes, sir.
Okay. This information is given to you. That is 10%. Okay. Okay. What is
Yes,
it
sir.
asking for you? What is it asking for you? It is asking for the molality and the mole fraction. Okay. Molality and
Yes,
the
sir.
mole fraction. So tell me that what do you mean by the molality of the solution? Molality.
Uh, like the definition.
Hmm?
You need the definition.
Yeah. No,
It's
not the definition formula. Formula.
it's mole by kilogram.
No. Yeah, mole by kilogram, but formula.
Moles
What?
of solute,
Moles of what?
solute
Solute
divided by
by
uh, mass of solvent in kilogram.
mass of solvent in kilogram. Very good. Mass of solvent in kilograms. Okay, very good. Now what we need to do here is number of moles of solute. What do you mean by number of moles? That is the formula for this one will be WB upon MB. Okay, divided by,
Yes,
if I'm taking the divide sign. Okay, this is the denominator. If I'm taking the divide sign, it will comes here. Okay, so I'm just writing the mass of solvent as WA. Okay, this is the
yes,
WB
sir.
number of moles, the given mass upon molar mass into. Okay, now what is saying in the question? It is saying glucose and the solvent is water. The solute is glucose. Okay, and the solvent is water. Solvent
Yes, sir.
is water. Okay, now tell me that this is molality WB upon MB into WA. Okay, is that
Yes,
okay?
sir.
Okay. Now tell me what information is given to you? That is 10. That the value of this one, the value of WB upon WA upon WA plus WB into 100 is 10. It is given to you. Okay. Now, now, what is WB? Given mass of solute. It is not given to you. Is it given to you? No, it is not given to you.
No.
Okay. Okay. So how can you convert this formula? Okay, because it is saying 10%. 10% of mass by mass percentage is 10. Okay. So if I'm saying 10%, what does it means? 10% W by W percentage. 10% W by W percentage. What does it mean? That 10 gram, 10 gram of solute is dissolved in 100 gram of solution. 100 gram of solution. Okay. So can you tell me that what is the mass of,
Sure.
can you tell me what is the mass of solvent in this one? What is the mass of this of solvent in this one? Can you tell me what is the mass of solvent in this one?
It's 10.
It is if I'm saying that let's simplify this one. If I'm saying that you have 20% W by W solution. Okay, so what does it mean? It means that 20 gram of substance is present in 100 gram of solution. Yes. Okay, per 100 grams of solution. If I'm
Yes.
saying 50% W by W means 50 grams of solute is present in 100 gram of solution. So if I'm saying 20% of a substance or a solute is present in 100 gram of solution, so what is the mass of solvent in that one?
Oh, 120. Or is it?
Let you
Oh,
listen carefully. If I'm saying in a solution which is
yes, sir.
100 gram, 20 gram is solute. So what is the amount of what is the mass of solvent in that one?
100,
No, it would be 80.
80. Okay.
Okay, 80 gram solvent plus 20 gram solute will gives you 100 gram solution. Is
Yes,
that
sir.
okay? You
Yes, sir.
understood? Okay.
Yes, sir.
So if you need to find out the molality, okay, W by W. Okay. So here we have W by W. So tell me, what is the mass according to this one given mass of solute? If it is not given, but we will assume that it is 10 gram because it is saying 10%.
10.
Okay. Okay. Got it. What is the molecular
Sure.
mass of glucose? C6H12O6.
Molar mass of glucose is 6H. So it's 180.
Yes, very good. It's 180. We'll put 180. Okay, very good. Okay. Then can you tell me that what is the mass of, what is the given mass of WA means given mass of solution solvent. What is the given mass of solvent?
Um, Given mass of solvent is one. Uh, Wait, hold on.
Hmm? Given mass of solvent. It's 90 na?
Yes, sir.
You have assumed that the solution is 100 gram.
Yes,
The
sir.
solution is 100 grams. So
But
out of that 100 grams, 10 gram is glucose. 90
yeah,
gram is
but
water.
yes, sir. But
Okay.
if the density is
Yeah, it is given to you.
1.10
That is
gram.
for the molarity. This is for the molarity. It is asking for the molarity. It is asking mole
Oh,
fraction, and this density will be used in the molarity.
okay, sir.
Okay.
Okay,
So
sir.
what is it? It would be 90. You have to write here 90 WA. So according to
Yes,
the
sir.
information, this is given to you 10%. So what does it 10% means? 10% W by W means you have to figure out the information of this one. That in that 10%, if we assume the total mass of the solution as 100 gram, that in that 100 grams, 10 gram is solute, 10 gram is solute, and 90 gram is solvent. Okay.
Yes, sir.
Because W by W means, because W by W means given mass of solute, okay, given mass of solute or mass of solute upon mass of solvent, sorry, mass of solution into 100, okay, in the both.
Okay.
But, you need to keep in mind here one thing, that this mass of solvent should be in kg. And we have assumed this mass in grams and this one also in grams. 10 grams, this
Yes,
10,
sir.
we have assumed the total mass of the solution is 100 grams, not the 100 kg. And molecular mass is always in grams. So we write it 180 grams and this also in grams. So this will be also in grams because if it is 10 grams, so it will be 90 grams mass of solvent. So what we need to do here is that in that case, if it is not in kg, if it is in gram, then we have to multiply here by 1000. So we have to multiply here by thousands. Is that okay?
Yes, sir.
Okay. So what find the approximate answer according to you. What would be the approximate answer?
So, let's see.
We'll cut 0 with 0.
Yes, sir.
We'll cut 1 0 with this one. You will have 100 upon 80, 18 into 9. Okay.
Yes,
So you cut it further, you will get 50 upon 81. 9 9 is 81. Okay. And then you will place 50, you will get 80. Okay. You put the decimal here, you will get 0. Then 81. 6 are 8 6 are 48, 486. Okay.
it's 0.661.
0.61. 0.61.
Yes, sir.
That might be 0.61. So this is an approximate answers. Okay. So
Yes.
similarly, what would be the mole fraction of each component of the solution? Mole fraction. So what is mole fractions? Tell me, what is mole fraction? Mole fraction.
Um, mole fraction.
What is mole fraction? Of each component of the solution. Each component means it is asking for the solute as well as solvent. So mole fraction
Yes,
of
sir.
solute. What is the mole fraction of solute? We represent it with xb, and it is the
Yes,
number of moles of B divided by number of moles of A plus number of moles of B. A, you know, A is stand for solvent and B stand for solute. Okay, is that okay?
yes, sir.
Got it? Okay. The same question is given to you. Now tell me, how will you find the number of moles of B?
Um, number of moles of B.
Hmm.
So we minus solvent from the solution.
Hmm?
We'll subtract the solvent from solution.
Thameem, what you doing? We have just find out the moles here. You can check it. B, WB upon MB.
Yes,
Given
sir.
mass upon molar mass. What is number of moles? Tell me. No, it's okay. It's okay if you have not done this one, then we will keep on practicing this chapter every day. We'll move to the next chapter because sometime needs a lot of practice. Let me explain you that. For example, you start writing with your left hand, okay, for the first day. And if I am teaching, if I ask you to write best in a best handwriting as you write in the with the right with your right hand, will you be able to write it with your left hand in a single day? Even if
No,
you
sir.
practice for 100 page, you will not.
Yes, sir.
Some changes require a lot of learning. So when you keep on learning this chapter every day, when you in every class before half an hour, we're going to have this class and we'll start to the next chapter, electrochemistry, where it is not a tough portion. You can do that one very easily because there are 2 or 3 numerical problems and numerical formulas, and you can do that one. So this chapter
Okay.
actually require constant learning and building a strong memory in your brain. Okay, if a teacher teaches you this chapter in a one go, it means every student will not get this one. Okay, why? Because this chapter requires slow learning. Slow learning. So slow means we are using this chapter half an hour for this class for this chapter, and we'll start 1 hour for the next chapter electrochemistry. Okay, is that okay? This is the way that I used to teach the students if they got stuck in this chapter. And the remaining portion of this chapter will keep on continuing with this. Okay. So this way
Okay.
we can move to the next chapter also. And the student will also feel that he is learning the next chapter also. He's not getting stuck in this chapter. So number of moles is given mass upon molar mass. Okay. So when you write it, keep writing. So when you write it, it will build your memory. Okay. And this will help you to figure out and your response, instant response. Given mass upon molar mass. Okay. So what
Yes,
is
sir.
the given mass here? Again, the same 10 gram because it is 10%. And what is the uh, molar mass of this one? Molar mass, tell me
Uh,
fast. Molar mass of glucose because it is glucose now.
yes, sir. 180.
180. So you put, so this is actually NB. Okay. Upon
Yes.
Na, number of moles of solute. Sorry, solvent. What is Na?
And A is
You can
for
you can write this NB here and Na here. It's your choice. It's nothing. So in some books it is written NB here plus Na plus Na. Okay, so this 10 upon 180. Okay, what is Na? What is Na?
number of solvent.
Number of moles of solvent. Okay, what is the number of moles of solvent? Again, you have to write the same formula, given mass upon molar mass. What is the given mass in the solution of solvent?
Uh, of solvent
Hmm.
is 90.
Yeah, it's 90 because we have assumed the whole mass of the solution is 100. Okay, and the what is solvent here in this question? What is solvent? There's the question. What is the solvent here?
Is water.
Water is a solvent. So what is the molar mass of the water?
Yes, sir.
What is the molar mass of water?
It's molar mass of water is H2O.
H2O.
Yes, sir. It is 18.
Very good. It's 80. So you have to multiply it by 10 so that it will also become 180. Okay.
Yes, sir.
Now this is 10 upon 180. Okay. And no need to make it 80, 180. Make all the 18. So this is already 18. You can make this one also 18. Okay. So
Yes, sir.
90 upon 18. 90 upon 18. Okay. And this you can cancel out and this you can also cancel out. So you can write it 10 upon 18. 1 upon 18. You can write it 1 upon 18 upon then you will get 18 upon 10. Okay, got
Yes,
it?
sir.
So what you will
Yes,
do? You will cut this one. You will get 1 upon 10 and 1 upon 10 is 0.1.
yes, sir.
Okay, if the mole fraction of XA is 0.1, what is the mole fraction of B? XB. So if XB is 0.1, what is the mole fraction of XA? XA.
Uh,
Hmm? What is the mole fraction of XA?
it is XA divided by
No, no, no.
X.
You know na XA plus XB is equals to 1. You have
Yes,
find
sir.
out XB. So what you will do?
Um, so it is moles of solvent divided by total moles of
1 minus
solution.
XB. You have
Okay.
forgotten each and everything that we have studied in the previous classes. XA is equals to 1 minus XB. That would be 1 minus 0.1. That would be 0.9.
Yes, sir.
Okay, the sum of two mole fraction of solute or solvent plus mole fraction of solute is equals to 1. So if you find out this one, no need to find out this one. Just subtract it. Okay,
Okay, sir.
is that okay?
Yes, sir.
Clear? Okay. So let's move to the next question. And no, we have another part of also this one also. What will be the molarity of the solution? Molarity. What will the
Uh,
molarity of the solution? It is asking for the molarity. Molarity.
Yes, sir. So mass of solute,
So what is the formula of molarity of the solution?
moles of solute divided by mass of solvent.
Moles of solute divided by,
Oh, that is molality actually.
it is molarity.
Yes, sir. So molarity is oh, it's divided by liters of solution.
Yeah, it will be volume of solution. Okay. So that will be volume of solution.
Yes,
Volume
sir.
of solution in liter. If it is not in liter, what we need to do?
We have to convert it to liters.
Multiply here by 1,000 if it is in ml. Okay. Got it?
Yes, sir.
Okay. Now just keep in mind volume of solution. Now, if I'm saying the number of moles is WB upon MB. Okay. WB upon MB. Got it?
Yes, sir.
Got it? This is given mass of moles of solute. Okay. Volume of solution is, what is the volume of solution? Volume of solution will be mass of solution. Mass of solution.
Yes, sir.
What is the relation between volume and density? Tell me. Density is equals to mass upon volume. Okay. Density is equals to, tell
Yeah.
me, density is equals to mass upon volume. I'm
Yes,
just
sir.
teaching you each and everything in a detail. Okay. Density is equal to mass upon volume. Okay. So here it is, we need volume here. So what will be the formula for the volume of solution?
Mass by density.
Okay, it will be mass by density. Okay. So this is that one. If I'm writing here, it can be mass by density. But the given mass of solution, okay, given mass of solution and divided by density of the solution. Okay. So mass of solution and divided by density of the solution. Okay. And if the
Yes,
density we are dividing writing here, so it will goes up. You know this one. If we are having in denominator something in denominator and we are writing here density, so we don't write density here, we write in the numerator. Okay. Got it?
yes, sir.
Like in the previous one, we were
Yes,
just
sir.
converting it volume with, we have to divide, if it is not liter, we have to write it here 1,000 divided by 1,000. So where the 1,000 goes, it goes into the numerator. So same thing. If we are dividing the mass of solution with density to get the volume, so what we need to do here is we can write this density of solution. Density of solution. Is that okay? Okay.
Yes, sir.
Now, let me know. And if this mass, if you have density in gram per ml, gram per ml, okay, gram per ml. Don't you think that the volume here will comes in ml? It is not kg per liter, kilogram per liter. It is gram per ml. Density is given to you in gram per ml. So the density is in gram per ml, okay, and the mass of the solution is also in grams. So the volume of solution will comes in ml. Okay. So again, we have to multiply here by 1,000. Okay, because this mass is in gram. Okay, and density is in gram per ml. So we have to multiply it by 1,000 because this whole will gives you the volume of solution in ml.
Yes,
Okay,
sir.
so this is the formula. Are you okay with this one? You understood each and everything of this portion? That this is the
Yes, sir.
formula for the molarity.
Yes,
Okay,
sir.
molarity. Okay, mass of
Yes, sir.
solution. Okay, now it has been given to you WB upon this one. What is it? It has been given, or you can write it. That is 10 upon given mass upon molar mass. You can write it 10 given mass of solute upon molar mass of solute is 180. Density of solution is 1.2 into 1,000 upon mass of solution. What is the mass of solution?
So,
Mass of solution.
uh, mm, one 100.
Mass of
It's 100.
solution, we have assumed 100.
Yes, sir.
Yes.
100.
You understand? We have, because it was given since initially we were assuming this one, na? Because we have assumed the mass of the solution is 100. That's why we have the mass of solute as 10 gram because it is given 10%. Okay. And the mass of solvent we are assuming 90. Where does this 90 comes from? Where does this 90 come from? Because we have assumed that the mass of solution is 100. So its volume,
Yes.
okay. Okay. So its solute is, and its solute is 10 and its solvent is 90. Okay. So, but we have to keep the mass because it is the volume of solution, not the volume of solvent. Okay. So it is the volume of solution. So we have to write the mass of solution here. Okay. And density of solution. This is actually the volume of solution. Okay. You
Yes,
understood?
sir.
Is
Yes,
that
sir.
clear? So
Yes, sir.
here we have to write this one and we will write here 100. Now find out the value of molarity.
Yes, sir. So, divided by 0.66.
Yeah, it is. You can cut it. Okay. And that would be, you can cut, with these two zeros, sorry, one zeros, and you can cut these zeros. Okay. So you're going to have 1.2 divided by 18. You can get 10 here. You'll get 6 twos are 6 threes are. You'll get 2 by 3 into 10. Okay. 2 by 3 is actually 0.66 upon 10. So 1 0 will be all added here, 0.06 mole per liter. You understood?
Yes, sir.
So if you assume this one, you can have the, if W by W percentage is given to you. So we can have the simple formula for the, if W by W percentage is given to you and it is being asked for the molarity. So we can have the simple formula. You know that given mass upon mass of solution into 100. This, if we are taking these three things, one this one, and this one. So this is actually mass by mass percentage. Okay. Given mass, WB of mass of solute upon mass of solution into 100. Okay. This is what? Are you getting what I'm saying? These three things that I have circled. Okay. So
Yes,
the
sir.
remaining thing you can write it like this way. So remove this one, and this 100 from this one. Okay. If you remove this one, you can write W by W percentage into density of solution into 10 upon MB. This would be the molecular mass of solute. Okay. This will be the simplest formula for the molarity of the solution. Please note it down.
Okay, sir.
You done this one? When you done, please.
I'm in the
Done?
yes, sir.
Okay. So, Thameem, we shall be starting the electrochemistry from, okay, so leave some pages or because it should not wind up. See, I want you to continue this chapter. Whenever I say that we're going to study the solution, so you must start with that one, okay? So I'm just making a new session here for you, and this is for the
Okay, sir.
electrochemistry. Electrochemistry. So this chapter, actually, in this chapter, what we are going to study, we are just going to study the about the batteries and the convergence of electrical energy into chemical energy and chemical energy into electrical energy. Okay. So how we use chemical energy, how we use electrical energy. Okay. So we're going to study in this one. So what we are going to study here is that in this chapter is electrochemistry. Okay. Electrochemistry. This chapter is important, but does not require much knowledge of the previous chapter. So I just started this chapter. Okay.
Okay, sir.
Only the basic knowledge of mole, that if you have 2 mole, 3 mole, so that is the number, that is you can do this one. Okay. So if I'm saying electrochemistry, so electrochemistry is the chapter. So what is this? This is the branch of science that actually deals with the study of or convergence of chemical energy into the electrical energy. We are just converting chemical energy into the electrical energy or electrical energy into chemical energy. So this chapter usually deal with this one, electrochemistry. Okay. So the branch of science which deals with the interconvergence of electrical and chemical energy is called electrochemistry. And we have divided this chapter into electrochemistry into two parts. One is the electrochemical cells. Electrochemical cells. Electrochemical cells are those cells like you see in the battery, okay, in which the chemical reactions takes place and it is using okay. With there are the two types of cells, like you see a Daniel cell or a battery cell that you used to use in your clock, okay. In that cell, chemical reaction is taking place and electricity is being produced. Like you see in the lead acid battery for the inverter, in that we charge the battery get charged, and in that we have chemicals, okay, and that chemicals reaction is taking place inside that one and it is producing the electricity. Means electricity is the output by the chemical reaction. And some of the reactions, some of the electrolytic cells you have seen in the 10th standard or the 11th standard also, uh, that in which we give the electricity, like for during the electrolysis of water, we just kept a cell like this, okay, and in that cell what we do actually, uh, we just place the two rods and we give the electricity from with the help of battery. External electricity is given and we generally like this way, we generally have two rods here like this way, okay, and these rods actually are connected with positive terminals or negative terminals, okay, and they uh, are used in providing the chemical or chemical energy, or it help in the chemical reactions, okay. So in this we are just providing the energy and we are providing the electricity, and this electricity is used in helping or in convergence of or doing the chemical reactions, okay. So there are the two types of cells. One you see in the battery, okay, that use chemical reaction and convert it into electricity. Like in the generator and motor, you can see in the motor we give the electricity and it rotates, it start rotating, and in the generator we rotate the motor and it produces electricity. The same thing is for this one also, okay. Got it? Got it? So note it down here
Yes.
that it is the branch of science, it is the branch of science that deals that deals with the interconversion, with the interconversion of electrical and chemical energy, electric energy. Okay, got it down. Electrochemistry is broken, divided into two parts. Electrochemistry, we have two types of things that we're going to study. One is the electrochemical cells we're going to study. Electrochemical cells. And the second one is the conductance. Conductance.
Okay, sir.
Okay.
Yes,
So
sir.
here we have electrochemical cells are the two types of cells. One is the electrolytic cells. Electrolytic cell. Electrolytic cells. And another one is the galvanic cell or voltaic cell. Galvanic cell or voltaic cell. Write down. So conductance, first of all, we're going to study the electrochemical cells. Okay.
Okay, sir.
Now what happens in the electrolytic cells and in the galvanic cells? You see that in the electrolytic cells, what is going to happen? We need to give the energy. Okay. And when we give the energy, the reaction will take place. Okay, like for example, here we have refining of copper, or for example, if we need to electrolyze the water and produce the hydrogen gas, or we need to split the water and get hydrogen and oxygen gas. What we are going to do? Tell me, tell me, tell me. We need to keep on going. We need to keep on going, or we need to supply the energy continuously. Okay. So in the electrolytic cells, what we need to do is, Thameem, that we need to give the we need to give the energy.
Hello, sir.
Yeah.
Can you hear me? I
I
think I
can
got
hear.
stuck in between.
Yeah. Is it okay? Is I'm
Yes, sir.
audible to
Now it's
you?
fine.
Okay.
Yes, sir. You're audible.
So what we are seeing here in the electrolytic cells, we are talking about the electrolytic cells.
Yes, sir.
Electrolytic cell. Okay.
Yes, sir.
So in this, we give the energy and the reaction is going to take place. Okay. Means the energy is being supplied. Okay. We have positively charged anode. Anode is positively charged and the cathode is the negatively charged. And cathode is negatively charged. Okay. It is negatively charged. Okay. We can simply say here the gives free energy that you have studied means the spontaneous energy. The gives free energy is positive here. And when gives free energy is positive, means greater than zero, it means it is non-spontaneous. The reaction is non-spontaneous. Non-spontaneous means it does not work out of it. For example, like in the lead acid battery or in the cell, the battery cell that you use that is having charge. Okay, it when you apply when you need to get the energy, you can easily get it energy. It is keep on giving the energy. It will keep on going. Okay, but it does when you are having this type of cells, you need to keep giving the energy. But in the another type of cell, like you have in the battery cell, or in the clock cell, you need to use the energy. If you keep on using the energy, it will give you energy. So we'll say that this is the galvanic cell or the voltaic cell. This is the galvanic cell. This type of cell is the galvanic cell or the voltaic cell. Okay, this type of
Yes,
cell
sir.
that you have seen in the clock. Okay, this type of cell. Okay, but this is an electrolytic cell. This is an electrolytic cell.
Yes, sir.
Note it down. Make each and everything.
Yes.
So in the electrolytic cell, what is happens? Electrical energy is converted into chemical energy. Electrical energy is converted into
Chemical.
chemical energy. Okay. Second thing that is going to happen is that we have positively charged anode, because in this type of cell we have negatively charged anode, and in this type of cell we have positively charged anode. So here we have anode and cathodes. The negatively charged rod is called anode. Sorry, cathode, and the positively charged rod is called anode. So we have two types of rod here. That is, anode is positively charged, okay, and cathode is negatively charged. Okay, what we are talking about? We are talking all these points for the electrolytic cells. Got it? For the
Yes,
electrolytic
sir.
cells. So note this one. When you're done, please let me know.
Okay.
Done?
Um, I'm drawing this one, yes, sir.
Okay, okay, draw it.
Done, sir.
Okay. Now talking to this cell, some more points of this cell is that outside this one, the electrons, means the charge is carried by electrons. Okay, electrons are the charge carrier. Electron carries the charge, but inside this one, the charge is carried by the electricity is carried by the electric current flows with the help of ions, free ions. For example, if you have NaCl, if you add water to it, pure water will not conduct electricity, so there will be no. But when you add NaCl to it, so Na and positively charged ion and Cl minus ion, they keep on moving from one position to another positions, and that because of that, okay, it can uh, continuously uh, conduct the electricity. Okay, so one more point about this one, note it down, that in external circuit, circuit, in external circuit, flow flow is observed from flow of electron, sorry, flow of electron is observed from anode to cathode. Okay, while While in internal circuit, it is carried by, or we can say charge is carried by, charge is carried by, is carried by, is carried by ions. Okay, note it down.
Yes, sir.
Next one is galvanic or voltaic cell. Galvanic or voltaic cell.
Yes, sir.
Just a minute, let me send the assessment topic of yours.
And sir.
Okay,
Yes, sir.
galvanic or voltaic cell. Now, for example, if you have a cell, okay, let me make it short. We have this type of cell. What is observed here is that a person, scientist, okay, add a zinc rod in a copper sulfate solution. Let you understood the theory first. He add a copper sulfate solution, and this is a copper sulfate solution, and he add a zinc, and he add a zinc rod or a zinc metal inside it, okay, over it. That zinc plate over it. This is a zinc metal, okay. This is a zinc metal, and this is copper sulfate solution, CuSO4. What he observed after some times when he add zinc to the copper sulfate solution, he find that zinc actually displace the copper from the copper sulfate solution, okay, and and we'll simply say here, and form zinc sulfate solution, okay, which is colorless. It is blue in color. It is blue in color, and it is colorless. It is colorless. Almost all the copper it has displaced, and the copper get deposited over the zinc metal, okay. And he thoroughly observed that what actually happens. Why do it happens? Why when we are adding a copper sulfate solution, why we are adding when we are adding the zinc to the copper sulfate solution, why actually the color of the solution changes and why the zinc sulfate is forming? Simple reason is that because zinc is more reactive than copper, so it will displace.
Yes, sir.
Okay. So when it is going to displace this one, it is going to displace this one. Okay, it get displaced. So what actually happens here if we write this reaction? So what happens here that this is the copper 2 positive ion, which will be present here. Cu2 positive ion. Cu2 positive ion will be there. Okay.
Yes, sir.
And there will be SO4 minus 2 ions also. Sulfate ion, because it is in ionic form, SO4 minus 2 ions. So because copper sulfate will remain in aqueous solution like in the form of Cu2 positive and SO4 minus 2. Okay. So this is
Yes,
like in
sir.
this. So what is going to happen here that zinc is donating its electron and becoming zinc 2 positive. What happened here is that zinc atoms, which the atoms that are present in this zinc strip. Okay, these atoms are donating its electron and they are converting into Zn2 positive. Okay, they are converting into Zn2 positive and
Two.
donating 2 electrons. And when zinc changes to Zn2 positive, then what is going to happen? They will come into the ions. They will come here in the solution. Okay. It does not mean that it will
Yes,
remain in
sir.
the strip. It will donate the 2 electron and will remain in the strip. No. If the zinc, this is a zinc atom. If it become from zinc atom to Zn2 positive, then it will come into the solution and will form Zn positive ion. Got it? Got it?
Yes,
And
sir.
will donate 2 electrons. And what happens here is that the copper 2 positive ion which is in the solution, it will get this 2 electron. Copper 2 as a positive ion will get this 2 electron from the zinc and will get converted into copper solid. Now this copper ion will not remain in the aqueous form, will not remain in the soluble form, will not remain in the solution. It will become an atom and it will deposit over it, over this strip, and will place over this strip. Okay, got it? Got
Yes,
it?
sir.
So it means there is an exchange of electron is taking place. There is an exchange of electron is taking place. Zinc is donating its electron to the copper 2 positive ion, and copper 2 positive is getting electrons and becoming solid. Okay. So he said that if this exchange of electron is done here, if during this exchange of electrons, if we get some work done, okay, then this, because you know the motion of electrons, if the electrons is moving from one place to another place, it produces current. Okay, what is electrons? What is electric current? The flow of electron is called electric current. Okay, so if the electrons are moving, so it means they can produce electrical energy. So he did this experiment in the 2 separate beakers. What he take here is that he took a zinc sulfate solution and a zinc rod in it. Okay, he took a zinc sulfate solution. What he took? He took a
Zinc sulfur.
zinc sulfate solution in beaker 1. Okay, in beaker 1, it is zinc sulfate that is having Zn2 positive and SO4 minus 2. Zn2 positive and SO4 minus 2 ions. Okay, and here we have a rod here, a rod. Okay,
Yes, sir.
and this is a zinc rod. This is a zinc rod. Okay, and it is having a zinc sulfate solution, ZnSO4. And he make another beaker here, another beaker here. Okay, and this is a copper sulfate solution.
Yes, sir.
Okay. It is a copper sulfate solution. Okay, and he has copper in it, copper rod in it. This is a copper rod, solid copper rod. Okay, this is a copper. Okay, then he
Yes, sir.
connect these 2 rods, because zinc rod in the zinc sulfate solution will not do anything. Similarly, the copper rod in the copper sulfate solution will not do anything. So he connect these 2 rods. He connect these 2 rods with some electric bulb or something. Okay, so when he connect these 2 rods, okay, the electron will start flowing. Okay, zinc from here, zinc 2 positive from here will start donating the electrons. Okay, they will start donating the electrons, and these electron will start going from here. It will start going from here. Okay, and going here, and from this copper 2 positive, okay, they are adding this copper 2 positive, the electrons, the copper 2 positive are getting 2 electrons, and it is getting copper solid. It is converting into copper solid. Means he did this experiment, which was done in the single beaker. He did this experiment in the 2 separate beakers, and connect the rods with the, tell me, with the wire. And you know that the electrons, if electrons are moving, so what he does, he in between kept electric bulb in between, because you know the flow of energy. Okay, because there is a flow of electrons, so it will have some electrical energy. So he wants to get work done, okay, by that energy, which is due to the flow of electrons. So he make a bulb here, or a voltmeter. You can say it is a voltmeter, or any meter, any work done. Okay, that can measure the current. So this is the bulb here, or anything. Okay, small bulb with very less voltage. Okay, so what he
Yes, sir.
actually does here is that these electrons are moving. These electrons are moving. Okay, and when the electron flow, this bulb will glow. Okay, and what is going to happen here is that this zinc Zn2 positive, zinc in this rod, zinc atoms, solid atoms. The solid atoms means of the rod atoms. They are not carrying any charge, because these are the atoms. Okay, so this zinc atoms are getting converted into Zn2 positive, and the 2 electrons will goes from this through this wire, Okay, and one of the zinc atom from this rod will come into this solution and in the form of Zn2 positive ion. Okay, what I'm saying
Yes,
here
sir.
that one of the atom from this zinc rod, this is the Zn atom, Zn atoms in this rod. One of the zinc atom will donate this electron and will form Zn2 positive, and this zinc at ions. Then now this is zinc ion. This is zinc ions, and it will come into this solution. Got it?
Yes, sir.
Okay. Now just listen to me. Now this ions comes here. Okay, and what is happened when these electrons comes? So the copper ions. Now this copper ion which is in the solution, the copper ion which is in the solution, this copper ion which is in the solution will get the two electron with the help of this rod, will get the two electrons and will get converted to solid. Now this copper ion will not remain in this one. It will get stuck and will form the copper atoms, and it will deposit here. Okay, got it?
Yes, sir.
Got it? Understood each and
Yes.
everything. So if
Yes, sir.
this reaction keep on going, what is going to happen after some time? What is going to happen after some times? This Zn2 positive concentration will increase in this solution because
Yes, sir.
one by one the atom will get converted into Zn2 positive, Zn2 positive. Okay, and the concentration of Zn2 positive will increase in the solution. Okay, means more and more Zn2 positive will be there. Got it?
Yes, sir.
And what is going to happen in this solution? The concentration of Cu2 positive ion will keep on decreasing because one by one the copper ion will get converted into copper solid and will get stuck. Okay, so it will be less in the amount. Okay, so what after the sometimes what you will feel that in the solution A, in the solution in the beaker A, if this is a beaker A, so in the beaker A you will find more number of Zn2 positive, as comparison to the sulfate ion, SO4 ion. Okay, more number of. And in the beaker B, what you will find? In the beaker B, you will find that there will be very less amount of copper 2 positive ion because they are one by one getting converted to copper solid. So it will be more in the concentration is SO4. SO4 minus 2 will be in more concentration. Okay, got it.
Yes,
So
sir.
after some times he see that the flow of current stops, means the bulb will not glow. Why does it happens? It happens because why the bulb get stopped? Why the bulb is not glowing here? Just because you need to concentrate here, Thameem. Just because after some time, okay, after some time, when there will be more and more positive charge in the solution, okay, will it allow the negatively charged particle to move, electron
No,
to
sir.
move? No. Will you think that if there is more and more positive charge, so what does the positive charge? Positive charge attract the negative charge particle. So if the electrons are moving from this, it will not allow it to go. Will say, no, no, we are positively charged. We are more in power. You cannot go. So if the concentration of Zn2 positive ions increases, simple, in a very simple manner, the electrons will not go. Okay, because this solution will become electropositive. And this solution will become electronegative. This solution will become electronegative. Why? Why this solution will become electronegative?
Um,
Because the
is it?
copper 2 positive ion, initially it was having one copper 2 positive and one sulfate 2 negative. Okay, one copper 2 positive, one sulfate. But one by one, these copper ions are converting into copper solid and they are depositing over the rod. So charges of this one is getting reduced and more sulfate ion are increasing. So it is negatively charged. So if the negatively charged, and you know negative repel each other. So will due to increase in the negative charge on this rod, they will repel the incoming electron because they are already, because the solution is already negatively charged, and if the electrons are coming, they will repel. So in the beaker A, they are not allowing the electron to go. In the beaker B, they are not allowing the electron to enter. If some of the electron come from this one, they will repel it. They will not allow. So what would happen is the current flowing through it will stops. Okay. Okay.
Yes, sir.
So what he does here, he uses a salt bridge. What he does, he uses a salt bridge.
Yes.
Okay. He uses a salt bridge here. Okay. And here is zinc. What is this one? Okay. It's not working. Okay. And here is zinc sulfate solution in this one, zinc sulfate.
Yes.
And here in this copper sulfate. And this rod is of copper. This is the copper sulfate solution, CuSO4. And this rod is Z. This is ZnSO4. And this rod is of zinc. And this rod is of copper. Copper. Okay. Cu. And this is a salt bridge. Salt bridge. Okay. This is a actually salt bridge.
Yes, sir.
Okay. And what is the role of salt bridge? That this salt bridge have a chemical compound in it. Okay. A chemical compound in it, and which are almost having means a chemical compound which is having ionic salt in it. Ionic salt. Okay. Like for example, this is called KCl. In the salt bridge, the salt is like, for example, KCl. What is the quality of the salt in the salt bridge? Okay. What kind of salt bridge should be there, and what is the quality for this one? That the size, the size and the charge of positive and the negative ion must be always almost same. For example, the potassium has valence electronic configuration 2881, and that of chlorine is 287. So they almost have same. And when you remove this electron, remove one electron from it, it will become 288 and become K1 positive. And when it becomes Cl minus, you add one electron to it, it becomes Cl minus, it has 288. So they have all three shells. They have almost same size, and they have one positive and one negative charge. Okay. So what is going to happen here is that in this K positive and Cl minus and K positive and Cl minus and K positive and Cl minus, so when this solution will become positively charged due to increase in the Zn2 positive. Okay. Okay. Zn2 positive ion, because one by one the atoms are zinc atoms are converting into Zn2 positive. So the equal amount to balance this charge, this Cl minus ions from this salt bridge will enters into this area. Okay. So Cl minus ion, because having K positive and Cl minus ion. Okay. So what is going to happen here is that this Cl minus ions one by one will come to this one, and it will balance it. Okay. You understood? Yes or no?
Yes, sir.
Okay. And when Zn2 positive here, and we are adding Cl minus ion to it, so again it will become neutral. Two positive and two negative ions are coming, so it will become neutral. And similarly, this solution is increasing with sulfate ion because the copper ions are depositing here. Okay, depositing here. So the potassium ions from this one will enters to this solution, and will due to increase in K positive ions, then it will again balance the sulfate ions. Okay.
Yes,
Okay.
sir.
And the electrical
Yes.
neutrality is again maintained. Okay, due to imbalance in the previous case when there is no salt bridge, and you will facing here problem because of in big array there is a positive concentrations of positively charged ions concentration is increasing. Here in this one, this negatively charged ion concentration is increasing. This is called imbalance in electrical neutrality, and due to imbalance in electrical neutrality, the current will not flow. After some time the current will stop flowing. Okay, so we need to add a salt bridge. And what is the role of salt bridge? That it help in maintaining the electrical neutrality, okay, of the solutions. You understood?
Yes, sir.
Okay, very good. So this time the electrical neutrality is maintained by the salt bridge. And what is the quality of that salt in the salt bridge? That it must have the same positive, the charges of the negative and positive ion should be same, because they, like you see that K is having one positive charge and Cl is also having one negative charge, and they must be all same size. It does not mean that if you are having a very atom which is very bigger in size and it is moving like you have a fat man, one you have a positively charged, let imagine there is a person who is having a positive charge and he is very fat, so he will move like slowly. Oh, okay, I am coming. Till then, the thin, or we can say that person, a normal person, okay, which is having a negative charge, they can run into this one again. Means if it should
Yes, sir.
not be like that, the two positive charge are entering here. Till then five negative charge are entering in this one. So it should not be like this. Okay, the equal amount of charges should be, if two positive charge ions are entering in this one, two positive charge means two potassium ions are entering in this one, at the same rate, the 2Cl minus ion should also enter in this one. And this is only possible if they have the same velocity in how and how can, and charges also, and how the velocity can be maintained. It can be maintained if their sizes are same. Okay,
Yes,
you
sir.
understood?
Yes, sir.
Surely, are you sure?
Yes.
Okay.
Yes, sir.
So this is a cell in which the zinc and zinc sulfate and a salt bridge of potassium chloride here are having, and this is known as Daniel cell. What we called it? This is a Daniel cell. Okay, this is the Daniel cell.
Yes, sir.
This is Daniel cell. Daniel cell. Okay, this is Daniel cell, and especially named for the copper sulfate solution and the zinc sulfate. Means this theme: zinc rod, copper rod, zinc sulfate, copper sulfate, and KCl with the copper. Okay, semi-solid paste of KCl. Okay, it is not exactly solid, it is not exactly liquid, it is semi-solid. Semi-solid paste of something is used here. Okay, so this is semi-solid paste of KCl is being used here. Semi-solid paste. Okay, so please draw this one. Semi-solid paste. Solid paste of KCl is being used here. Okay, can you tell me, can you guess that in this, which can be the positively and negatively charged rod? Which can be the positively charged rod here, and which can be the negatively charged rod here?
Oh,
Which can be the positively charged rod?
the the copper.
Yeah, copper will be the positively charged rod. Okay, because what is happening, you know that electrons are flowing from this to this. Okay, an electron always from negative terminal to positive terminal. Okay, okay, you got it?
Yes.
But this will be named as anode. This is anode, but it is
Mm.
negatively charged. Negatively charged. Okay, and this one is cathode. This one is cathode. Okay, this one is cathode, but it is positively charged. Why? Because it is receiving the electrons, and once that receive the electron is known as uh, positive. This is positively charged. Okay, and why in the galvanic cell, sorry, in the electrolytic cell, anode is positively charged, and here it is negatively charged. In this galvanic cell, anode is negatively charged, but in this electrolytic cell, anode is positively charged. Why it is so? Why it is so? because in this the electrons are coming from negative and this is entering here. So this is negatively charged rod is cathode here. Why? But there is a reason, because at anode always the oxidation is take place. At anode always, whether it is electrolytic cell, whether it is galvanic cell, at anode always oxidation take place. Oxidation takes place. And removal of electron is oxidation. Removal of electron is oxidation. Okay. And at cathode always reduction take place. Always reduction takes place. Okay. And addition of electron is reduction. So in the electrolytic cell, so let's take the galvanic cell first. In the galvanic cell, where the removal of electron is taking place? At the zinc rod, na? At the zinc rod, you will
Yes.
face that there's a zinc atoms and they are removing the electrons. It is going like this way. Okay, it is going from here and it is converting into Zn2 positive. So here X oxidation is taking place. So this is anode. According to the rule, on anode oxidation should done. So according to the rule, this is anode. Okay, and why it is negatively charged? Because from the negative charge, negative rod, only the electron can go. So since the electrons are moving from here and they are moving from to this direction, so this should be negatively charged rod. Okay, because electrons can move from negative to positive terminals or negatively charged. Okay, understood? Got it?
Yes, sir.
Yes or no?
Yes,
Clear?
sir. Yes, sir.
Okay, and at cathode there is always reduction take place. Why it is so?
Oh, because of
At cathode
oxidation.
always the reduction take place. Why it is so? Yeah, because and the addition of electron is, this is the rule. At anode always reduction takes place, addition of electron. So you see that at the in the copper rod here, in the copper rod there are copper atoms and this is the copper atoms, not the positive charge. Okay, and they are the copper 2 positive ions and they are getting the electrons and they are converting into Cu2 positive ions are getting the electrons and they are converting into copper solids. So here this is known as reduction, because here cathode addition of electron is taking place. So this is cathode according to the rule. And why it is positively charged? Why it is positively charged? Why it is positively charged and why it is negatively charged? The reason, because the electron is received by the positively charged rod, because electron move from negative rod to positive rod. So it is positive charge. Okay. Understood?
Yes, sir.
Okay.
Yes, sir.
Next, in the electrolytic cell, like for example, if I'm having this electrolytic cell and we are supplying the energy, okay, like for example, this is the positive terminal and this is the negative terminal. This is an electrolytic cell. And in the electrolytic cell that I'm having, this is Na solid and a positive ion. And this is a solution of aqueous solution of brine. Na positive ions and Cl minus ions are there. Na positive ions and Cl minus ions are there. Okay. So what you will observe
Yes,
here,
sir.
that this is the positively charged rod and this is the negatively charged rod. Okay. Okay. So you know that electrons, the electrons move from negative terminal to positive terminals. Okay. So what is going to happen here? The electron will go from here because it is negatively charged. It is connected with the negative rod. Okay.
Yes, sir.
Okay. Electrons are going. You know that always negative from negative charge rod, the electrons move. So they are moving. Okay. They are coming here. So what is going to happen? So at this rod, Na will receive the electrons. Na positive ion will receive the electrons and will get converted into Na solid. And addition of electron is known
Yes,
as
sir.
reduction. Addition of electron is known as reduction, that we have written here. Addition of electron is known as reduction.
Reduction.
So addition, for according to this the rule, that this rod, at this rod, since reduction is taking place, so it should be cathode. Okay, it should be cathode. According to this rule, it should be cathode, because here the reduction is taking place, addition of electron is taking place. Na positive ion from this solution will goes and will receive the electron from the battery and will get the okay, will get the electrons and will get converted into Na solid. Okay, okay, is that
Yes.
clear? But
Yes, sir.
since the electrons is received by it, electron is received by it, so receiving electron, electrode, the electrode that receive the electron, okay, it is negatively charged. Okay, so this is the negatively charged. So this is negatively charged. Okay,
Yes, sir.
negatively charged. Okay. Similarly, at positive terminal, what is going to happen? The 2Cl minus ions will comes and they will lose their 2 electrons and will form chlorine gas, and 2 electron will be removed. Okay, these are the 2 chlorine atoms and they will remove the electrons. So here, removal of electron is known as oxidation. Is known as oxidation. Okay, and this is oxidation. So oxidation is done over here at the at this positively charged rod, and this is known as anode, because it, according to this rule, uh, according to this rule, removal of electron is known as oxidation. And where the oxidation take place, it is always done at anode. Oxidation is always done at anode. So a removal of electron is taking place at this rod, and so it should be anode. And why it is positively charged? Because it is connected with the positive terminal. Okay, because
Yes.
it is, because here the electron is withdrawn by the electron can be withdrawn by the positively charged. Negatively charged rod cannot withdraw the electron. How can a negatively charged rod can withdraw the electron? A positively charged rod can withdraw the electron from something. So here the withdrawing of electron is done by anode. So that's why it is positively charged, a positively charged rod. So this is opposite. In the electrolytic cell, which is connected with the battery, okay, and the chemical reaction is taking place, in that anode is positively charged and cathode is negatively charged. But in the
Yes.
galvanic cell, or in the Daniel cell, or in the voltaic cell, anode is negatively charged, and cathode is positively charged. But in both the cell, whether it is electrolytic cell or the galvanic cell, both the cell, oxidation will take place at anode and reduction will take place at cathode. You understood?
Yes, sir.
Okay. So please note each and everything here. Put it written here. Have you drawn this one? Tell me if yes or no. Have you drawn this one?
Not yet, sir. I have to draw.
You have to draw it.
Yes, sir. Done, sir.
Note this one also.
Okay, sir. Done, sir.
Do this one also.
Done, sir.
Okay. So I need to write each and everything this one, that in the galvanic cell or the Daniel cells, chemical energy is converted into electrical energy. Okay, anode and cathodes. Anode is called negatively charged, and to cathode is called positively charged electrode, respectively. Oxidation take place at anode, and uh, reduction take place at cathode. Okay, and so and what are the characteristics of the salt bridge? Means what is the characteristics of salt bridge? Because this is an important topic, that the question comes that what should be the characteristics of the salt in the salt bridge. Okay, that it must have the same size almost, they must have the same charge. Okay, size of the mobility of the conductance of cations and ion must be same. Okay, or they should not be kept for long, means okay. So
Yeah.
they should be in that state that they can work for long. Okay, like in semi-solid state. Okay, they must have almost same size, because this is very important. So the characteristics of salt bridge and uh the the information that we have discussed today, either you can write it by your own, or in the next class I will help you to write this one. Okay, got it?
Yes, sir.
Got it, Thameem? So keep
Yes,
practicing
sir.
the questions that we have done from the solution chapter, and if you are stuck in that one, so it is not your problem, it is normal for everyone. Okay, it is normal for
Okay.
everyone, because you are not, because we are keep on practicing, we are in the practice, but you are studying this one for the first time. So it is just it is a similar condition for you, that is you start writing with your left hand today. So can you
Yes,
imagine,
sir.
will you be able to write it with that speed that as you are able to write with your right hand? No, same condition. When you keep on practicing each and every day, slow learning, then it will help you. Okay, so that's all for today. We'll meet you in the